Good day guys, welcome to 5 minutes with Faraday. In the previous video, I explained electronic configuration and how to determine the block an element belongs to in the periodic table. So in this video, I will explain how to determine the period and group an element belongs to in the periodic table. So let's get started. Let's take the first example, silicon. Silicon has an atomic number of 14, therefore 1s2, 2s2, 2p6, 3s2, and 3p2, where 2 plus 2 plus 6 plus 2 plus 2 is equal to 14. Now, to get the period silicon belongs to in the periodic table, let's take a look at the last orbital here, 3p2. The alphabet here is P. The coefficient of the alphabet is 3. Therefore, silicon belongs to period 3 in the periodic table. To get the group, the power here is 2. But when you take a look at the preceding orbital, 3s2, the coefficient of the alphabet is also 3. 3 and 3 are the same. Therefore, you have to add the power together. 2 plus 2 is equal to 4. Therefore, silicon belongs to group 4 in the periodic table. Let's take another example. Sodium. Sodium has an atomic number of 11. Therefore, 1s2, 2s2, 2p6, and 3s1. Where 2 plus 2 plus 6 plus 1 is equal to 11. To get the period sodium belongs to in the periodic table, take a look at the last orbital, 3s1. The alphabet here is S, which is the block, but the coefficient of the alphabet is 3. Therefore, sodium belongs to period 3 in the periodic table. To get the group, the power of the last orbital here is 1. But when you take a look at the preceding orbital, 2p6, the coefficient is 2. 2 and 3 are not the same. Therefore, you have to take the power of the last orbital as the group sodium belongs to in the periodic table. Therefore, sodium belongs to group 1 in the periodic table. Let's take a look at the third example. Magnesium. It has an atomic number of 12. Therefore, 1s2, 2s2, 2p6, and 3s2, where 2 plus 2 plus 6 plus 2 is equal to 12. To get the period magnesium belongs to in the periodic table, let's take a look at the last orbital, 3s2. The coefficient of the alphabet here is 3. Therefore, magnesium belongs to period 3 in the periodic table. To get the group, the power of the last orbital here is 2. But the preceding orbital, 2p6, the coefficient is 2. 2 and 3 are not the same. Therefore, you have to take the power of the last orbital as the group magnesium belongs to in the periodic table. Therefore, magnesium belongs to group 2 in the periodic table. The fourth example, chlorine. It has an atomic number of 17. Therefore, 1s2, 2s2, 2p6, 3s2, and 3p5, where 2 plus 2 plus 6 plus 2 plus 5 is equal to 17. To get the period chlorine belongs to in the periodic table, we have to take a look at the last orbital here, 3p5. The coefficient of the alphabet is 3. Therefore, chlorine belongs to period 3 in the periodic table. To get the group, the power of the last orbital is 5. When we take a look at the preceding orbital, 3s2, the coefficient is 3. 3 and 3 are the same. Therefore, you have to add the powers together. 2 plus 5 is equal to 7. Therefore, chlorine belongs to group 7 in the periodic table. Let's take the fifth example. Carbon. It has an atomic number of 6. Therefore, 1s2, 2s2, 2p2, where 2 plus 2 plus 2 is equal to 6. To get the period carbon belongs to in the periodic table, let's take a look at the last orbital, 2p2. The coefficient of the orbital is 2. Therefore, carbon belongs to period 2 in the periodic table. To get the group, the power of the orbital here is 2. When we take a look at the preceding orbital, 2s2, the coefficient is also 2. 2 and 2 are the same. Therefore, we have to add the powers together. 2 plus 2 is equal to 4. Therefore, carbon belongs to group 4 in the periodic table. So guys, If you haven't subscribed, please do that so as to get notified when I post another video. And please help me push the like button. Thank you.